Hi guys. Hope you're feeling good. We're jumping into O-level chemistry lesson 1, rates of reaction. Rate of reaction measures how quickly reactants are consumed or products formed, in moles S or G over S or cm cubed over S. Collision theory states particles must collide with sufficient energy, equals EA, and correct orientation. Frequency of successful collisions determines rate. Concentration effect. More particles per dm cubed increases collision frequency, so rate rises. Pressure increase for gases has the same effect. Temperature increase gives particles higher kinetic energy, so more collisions exceed EA. Rate increases sharply, roughly doubles per 10 deg C for many reactions. Surface area. Powdered solid reacts faster than lumps because more particles expose surface for collision. Catalysts provide alternative pathway with lower EA, increasing successful collisions without being consumed. Enzymes are biological catalysts. Measuring rate, gas syringe volume versus time, mass loss versus time for CO2 escape, color change and titration samples at intervals. Graph rate versus time falls as reactants are used up. Gradient of concentration time graph at a point gives instantaneous rate. Industrial importance. Haber process balances rate and yield. Contact process uses V2O5 catalyst. Storage of food in fridges slows bacterial enzyme catalyzed reactions. Explosions are extremely fast exothermic gas-producing reactions. Experiments compare variables fairly, one factor changed, others constant. Plot graphs with axes labeled and describe trend. Steeper initial gradient means faster rate. Explain every factor with collision theory language, not vague more energy alone. Measuring initial rate from the steepest part of a graph allows fair comparison between experiments started at different times. When explaining experimental results, link each observation to collision theory. A flatter curve means fewer successful collisions per second, not necessarily that collisions have stopped entirely. The rate of reaction decreases as reactants are used up because their concentration falls, reducing the frequency of successful collisions. A rate time graph therefore levels off as the reaction approaches completion, even though particles continue to collide without reacting. Catalysts are unchanged chemically after a reaction and can be recovered with the same mass, though their surface may need cleaning in industrial plant. Enzymes in living cells are highly specific catalysts whose activity falls if temperature or pH moves outside the optimum range. A clock reaction can show color change after a fixed time that depends on concentration, providing a vivid classroom demonstration of how rate responds to reactant concentration at constant temperature. State factor changed, predict effect on collisions, link to graph gradient or observation, control other variables. Zinc powder with acid produces H2 faster than zinc ribbon because greater surface area gives more frequent acid-zinc collisions. Do not say catalyst increases yield at equilibrium or ignore controlling variables in experiments. Practice. Why does increasing temperature increase rate? Answer. Particles move faster, more collisions have energy equals EA. Watch the numbers land in the matching symbols. Check that units cancel cleanly. If they do not, the setup is wrong even before the arithmetic. Practice. Name 2 methods to measure rate of H2 production from milligram plus acid. Answer. Gas syringe volume versus time, mass loss of flask versus time. Watch the numbers land in the matching symbols. Check that units cancel cleanly. If they do not, the setup is wrong even before the arithmetic. Okay, that's it for rates of reaction today. Next lesson we'll move on to reversible reactions and equilibrium. Take care, and I'll see you in the next one.